Now in lesson 3, we're going to start looking at what's called the ASCII code, and we're going to start looking at string length and how we can use string length in our programs to make them better. So by the end of today, you'll be able to explain and use the length, character, and ordinal number functions with strings. You'll also be able to explain what the ASCII code is and use it to perform different comparisons between words. So here it says the ASCII code. So if you haven't used the ASCII code before, this is a great time to take some notes on it. One thing to remember with the ASCII code is that computers can only read machine language. So if you read anything that a computer reads, it is a series of on and off switches that use 0 and 1s. A bit is a 0 or 1, and a byte is 8 zeros and 1s in combinations. And the ASCII code uses bytes, which are 0 and 1 combinations, to represent letters in code. So your computers can only read zeros and ones, so the ASCII code are actually numbers that represent various symbols in text. So your computer cannot understand or compare or store characters. It can't store a C as the physical C that you see it as here. It'll store it as a number that represents C. So that's what the ASCII code is. The ASCII code is the code where each character is represented by some sort of value. And every single character that you type into a string will have a number in binary that represents it. So here it says the ASCII code is 0 through 127, which is represented by 128 original characters. And they take up 1 byte of space in memory. So numbers 0 to 128 account for those, or 0 to 127, excuse me, account for those 128 characters, and they take up a byte or 8 zeros and 1s in memory. A special character will take up 2 bytes in memory. So anything beyond the codes of 0 and 127 will actually take up 2 bytes instead. And those can go up to much, much higher numbers. So first, looking at the ASCII code, this is a basic table of the ASCII code, and I'll have one for you that you can use, or you can simply look it up online. So this is a nice little chart that has 1s and 10s. So these are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, so on. And these are your 10s. So the way to read this is, for example, say we wanted the space. So SP is the space. It would be represented by 32. So the space is represented in the ASCII code by 32. The hashtag symbol that you use on Twitter so much is represented by 35. And you can see numbers in text. So this is where numbers and strings are different than numbers. 48 represents the string character of 0. 49 represents the string character of 1. So you can see it goes through special symbols, goes through numbers, goes through capital letters. And then what you'll notice here is that lowercase letters actually have their own set of values as well. So upper and lowercase are different when utilizing the ASCII code. So this ASCII code exists simply because we need to be consistent between all different computer types. And I like to think of it as a secret language between the computer and you. Each character is represented by a number in binary, so you could really write out a secret message by writing out numbers in binary using the ASCII code. When the computer encounters each letter, it simply translates the ASCII code into its appropriate variable, or into its appropriate character representation in your text. So your string comparison here, when you're checking for equality. So this is where you're going to write something like if string 1 equals string 2. So that's the example of what might be in your code. What it's going to do is it's going to go through and compare the strings character by character, starting with the first one. And what it's going to do is it's going to compare the ASCII code of each character in the string in order. 2 strings are then only equal if they are the same length and each index's characters are exactly the same, meaning they have the same ASCII code. This also means that your computer's, the ASCII code is case sensitive. So lowercase and uppercase characters of the same letter are different. So if we had something like if yes equals yes, this would actually turn out to be false because these two, the lowercase and the capital Y, are 2 different ASCII code values. So that's how that's going to work. Just kind of keep that in mind as we start looking at strings on the next few slides. So as I said, we have comparisons. They're going to use the ASCII code value. So for example, capital A is less than lowercase a. If we go back and look at our ASCII code, capital A is represented by 65. Lowercase a is represented by 97. So this is true because 65 is less than 97. We go and look at capital Z compared to lowercase a. Capital Z is represented by 90. Lowercase a is represented by 97. So again, this turns out to be true. For a word, it's going to go through and compare one at a time, but we know that uppercase letters have a lower ASCII code value than lowercase letters, so this will turn out to be false. And then numbers actually come before letters, so since 9 is represented by 57 and capital A is represented by 65, this would evaluate to be true. So a basic code to kind of remember is it generally goes symbols, numbers, uppercase, lowercase in the ASCII code. It's not a rocket science and exactly that, but this typically tends to be the case. Symbols followed by numbers, followed by the uppercase letters, followed by the lowercase letters with some variation in between, but that's a generalized idea. Okay, so for each statement below, what we're going to do is we're going to determine if the statement evaluates to be true or false. So this is where we need to use our ASCII code. So I'm actually going to copy it down here so that I can use it as I go. So here I have yellow equals yellow. So I'm checking character by character to make sure that every character has the same value and this is the same length. So we can already see it's the same length, but capital Y and lowercase y are not the same. And as a result, this would evaluate to be false. This next one, we're doing a less than or equal to. So we go and we compare the first character. Well, I know that uppercase characters are lower. I know that capital G is 71, while lowercase g is 103. So this would also evaluate to be false, simply because capital G has a lower ASCII code letter than the first letter here, which is a lowercase g. Here, we compare the first character. So we have uppercase B compared to uppercase P. So if we go look, uppercase B comes first at 66, uppercase P is 80. So this would evaluate to be true. Packers does not equal Packers. We know that the P's would need to be identical for them to be the same. So saying they are not equal is a true statement. It is cold today versus it is cool today. So if we go through, the I and the T are exactly the same, then they both have a space. The is identical, they both have a space. CO is identical. So what we're really comparing here to tell which is greater is the L and the O. So if we go into our ASCII code, again, we see that lowercase l is represented by 108 and O is 111. So this is saying that 108 is greater than 111 when comparing that. That is a false statement. So as a result, this would evaluate to be false. We know that symbols come first, so symbols have a smaller ASCII code than letters. So this one would evaluate to be false because the symbol would be smaller. We go through here, ABC, ABC, so we're comparing capital D and space. So space is 32, capital D is over here at 68, so the space needs to be smaller, which it is not. So this would evaluate to be false. And then this one, hello equals hello, would be correct and true if it was two double quotes around it. However, this is actually going to produce an error because the string is not in quotes. So kind of just keep that in mind. So that's how we can compare strings, and that's what will happen if you compare strings in your Python program, as it uses the ASCII code to make that prediction. So what you're going to do in this next part is you're going to actually do a investigation on these three new functions. So you'll need to pick that up from me. You're going to look at what's called the ordinal function, the character function, and the length function. And when you're done, we'll recap and work together and just kind of see how these work, and then we'll use them in our own programs.